Stepping onto the lunar surface, a giant leap or a giant lie? In 1969, the world watched as Neil Armstrong took one small step for man, one giant leap for mankind. The Apollo 11 moon landing stands as a pinnacle of human achievement. Or does it? A vocal minority contests this narrative. They claim the moon landing was an elaborate hoax. Believers point to supposed anomalies in the official record. They scrutinize photographs, dissect video footage, and analyze scientific data for inconsistencies. Was the American flag waving in the airless vacuum of space? Were the shadows inconsistent? Did NASA doctor the images? These questions fuel the ongoing debate. We will examine the historical context, explore the theories, and analyze the counter-arguments. Our journey will separate fact from fiction and explore the enduring power of conspiracy theories. Conspiracy theories are woven into the fabric of human history. They emerge from uncertainty, fueled by mistrust and fear. The moon landing hoax stands apart as one of the most enduring conspiracy theories. Why does this theory persist? The answer lies in a complex interplay of factors. Some struggle to reconcile the technological limitations of the 1960s with the enormity of landing on the moon. Others harbor a deep-seated distrust of government institutions. The internet age has amplified fringe beliefs and allowed misinformation to spread. The moon landing hoax has found new life in this digital landscape. This essay aims to provide a balanced examination of the facts, encouraging critical thinking. The moon landing hoax serves as a case study in the power of misinformation and the importance of scientific literacy. The 1960s were marked by intense geopolitical tensions between the United States and the Soviet Union, known as the Cold War. This period saw both nations vying for global supremacy across various domains, including space exploration. The space race was ignited on October 4, 1957, when the Soviet Union launched Sputnik 1. This event shocked the American public and spurred a sense of urgency within the US government. The Soviet Union's early lead posed a direct challenge to American technological superiority. In response, the United States rapidly accelerated its space program, establishing NASA in 1958. The space race became a symbol of technological prowess and national pride. Each achievement was a propaganda tool, showcasing the superiority of the respective political systems. The Soviets achieved several firsts, including sending the first human, Yuri Gagarin, into space in 1961. The race to the moon was a high-stakes contest with the world watching closely. Amidst the heightened competition of the space race, President John F. Kennedy made a bold declaration. On May 25, 1961, Kennedy announced the goal of sending an American astronaut to the moon and returning them safely to Earth before the end of the decade. This pronouncement was a strategic move in the Cold War. Kennedy's speech galvanized the nation and provided NASA with a clear objective. His declaration was driven by the need to restore American confidence, demonstrate technological superiority, and inspire a generation. The announcement set in motion a monumental effort. Significant funding was allocated, and a massive workforce was mobilized. The Apollo program was born, and its success became a matter of national pride. The technological hurdles were immense, and the financial cost was staggering. Nonetheless, the goal united the country in a common cause, embodying the spirit of exploration. The Apollo program, initiated by NASA in response to Kennedy's challenge, aimed at achieving a crewed lunar landing. The program built on the successes of earlier missions, including Mercury and Gemini. The Apollo program faced numerous technical challenges, including the development of the Saturn V rocket. This colossal launch vehicle was essential for carrying astronauts to the moon. Testing and perfecting the Saturn V required rigorous experimentation. The Apollo program also necessitated extensive training for the astronauts. They underwent rigorous physical and mental preparation. Simulations and test flights were critical in building confidence and ensuring safety. Despite setbacks, including the tragic Apollo 1 fire, the program persevered. Each mission brought NASA closer to the ultimate goal. The Apollo 11 mission, launched on July 16, 1969, represented the culmination of years of intense work. Astronauts Neil Armstrong, Buzz Aldrin, and Michael Collins were tasked with the historic journey to the Moon. The mission captured the world's attention, with millions watching in real time. On July 20, 1969, the lunar module named Eagle successfully landed on the Moon's Sea of Tranquility. Neil Armstrong became the first human to set foot on the lunar surface, uttering the iconic words. Buzz Aldrin soon followed, and together they conducted experiments, collected samples, and planted the American flag. The mission, while a triumph, was fraught with challenges. The astronauts had to navigate the module manually to avoid a rocky landing site. Despite these hurdles, the mission was executed successfully. Upon their return on July 24, 1969, the astronauts were celebrated as heroes. One of the most enduring aspects of the moon landing hoax theory centers around the alleged fabrication of the lunar landscape. Conspiracy theorists posit that the entire event was staged within a Hollywood studio. They point to the perceived artificiality of the lunar environment depicted in the photographs and video footage. They argue that the technology of the 1960s would have been incapable of transmitting live video footage of such high quality from the Moon. Further fueling this theory are claims that certain visual elements within the footage appear unnatural. While seemingly plausible, this theory crumbles under scrutiny. The sheer scale and complexity of constructing a believable lunar environment within a studio would have been an astronomical feat. The missing stars. Where is the celestial tapestry? Gaze up at the night sky and you will be greeted by a breathtaking tapestry of stars. This fact has become a point of contention for moon landing skeptics, who question why no stars are visible in the photographs and video footage taken on the lunar surface. The absence of stars in the lunar sky, they argue, is a smoking gun. They posit that NASA, in its haste to create a convincing illusion, overlooked this crucial detail. The explanation is rooted in the principles of photography and the unique lighting conditions on the Moon. The cameras used during the Apollo missions were equipped with fast shutter speeds and small apertures, rendering the faint light from distant stars undetectable. The absence of stars in the moon landing images is not evidence of a hoax. It is a testament to the careful planning and technical expertise of the photographers and engineers. The waving flag, a fabric of lies? Few images from the Apollo missions are as iconic as the sight of the American flag on the lunar surface. Yet this image has become a focal point of controversy, with conspiracy theorists pointing to the flag's movement as evidence of a terrestrial hoax. In the airless vacuum of space, how could the flag be waving? This question has fueled countless debates. The explanation lies in the design of the flag itself. NASA engineers devised a telescoping pole with a horizontal crossbar to keep the flag fully extended. The apparent waving motion is an artifact of this design. The waving flag is a testament to the meticulous planning and innovative spirit of the Apollo program. Shadows of doubt, inconsistent lighting, or lunar landscape. The play of light and shadow can shape our perception of depth and dimension. In the context of the moon landing hoax theory, the analysis of shadows in the Apollo photographs has taken center stage. Skeptics allege that inconsistencies in the direction and length of shadows betray the use of artificial lighting sources. They argue that if the sun were the sole source of illumination, all shadows should be parallel. However, in some photographs, shadows appear to converge or diverge. This observation fails to account for the influence of perspective and the uneven topography of the lunar surface. The presence of craters and hills can create variations in the angle and length of shadows. The shadows observed in the Apollo photographs are a testament to the interplay of light, perspective, and the unique characteristics of the lunar landscape. Section 5. The Van Allen radiation belts, a radiation-shielded reality or a fatal flaw. Surrounding Earth, like a protective shield, are the Van Allen radiation belts, two donut-shaped regions of charged particles trapped by the planet's magnetic field. These belts, named after their discoverer, James Van Allen, pose a significant radiation hazard to spacecraft and astronauts venturing beyond Earth's atmosphere. Moon landing skeptics often cite the Van Allen belts as an insurmountable obstacle to the Apollo missions, arguing that the intense radiation would have been lethal to the astronauts, making a lunar journey impossible. They question how NASA could have effectively shielded the astronauts from this invisible threat, suggesting that the missions must have been faked to protect the crew. While the Van Allen belts do indeed pose a radiation hazard, their intensity and duration of exposure are often exaggerated in popular culture and conspiracy theories. NASA, fully aware of the risks, took extensive measures to mitigate the radiation exposure experienced by the Apollo astronauts. Firstly, the trajectory of the Apollo spacecraft was carefully planned to minimize the time spent within the most intense regions of the belts. Secondly, the spacecraft itself, including the command module and lunar module, was equipped with radiation shielding to protect the crew. While the astronauts did receive a small dose of radiation during their journey, it was well within acceptable limits and comparable to the exposure experienced by medical professionals working with X-rays. The Van Allen belts, while a concern, were not an insurmountable obstacle to the Apollo missions, thanks to careful planning and effective radiation mitigation strategies. Section 1. The curious case of the parallel shadows. One of the most frequently cited pieces of evidence put forth by moon landing skeptics lies in the analysis of shadows in the Apollo mission photographs. They meticulously scrutinize the images, highlighting instances where shadows cast by objects on the lunar surface appear to be non-parallel. This, they argue, is a clear indication of a fabricated scene, suggesting the presence of multiple light sources, much like those found on a film set. In a world illuminated by a single distant sun, as is the case on the Moon, one would expect all shadows to be parallel. The skeptics contend that the non-parallel shadows observed in some photographs betray the use of artificial lighting, such as spotlights, commonly employed in film and television productions. This, they believe, exposes the lunar landscape depicted in the images as nothing more than a carefully constructed soundstage. The argument, while superficially convincing, crumbles under the weight of scientific scrutiny. What the skeptics often fail to consider is the effect of perspective. Just as parallel railway tracks appear to converge in the distance, parallel shadows on a three-dimensional surface, when projected onto a two-dimensional photograph, can create the illusion of non-parallelism. Furthermore, the lunar surface is far from a perfectly flat plane. The presence of hills, craters, and other topographical variations can cause distortions in shadow angles and lengths, even under the illumination of a single light source. These variations, when captured in a photograph, can further contribute to the perception of non-parallel shadows. Section 2. The enigma of the background craters. Moon landing deniers point to smooth backgrounds in photos, claiming NASA used painted backdrops. They argue the background should be as cratered as the foreground. However, this ignores atmospheric scattering and depth perception principles. Without an atmosphere, distant objects on the Moon appear less distinct. Section 3. The lunar module's dubious descent. The Apollo lunar module, a marvel of engineering designed to ferry astronauts to and from the lunar surface, has also come under scrutiny from moon landing skeptics. They question the feasibility of the lunar module's descent and landing, pointing to the lack of visible exhaust plume or dust disturbance beneath the module during its final descent. In the vacuum of space, rocket engines behave differently than they do in an atmosphere. On Earth, the exhaust plume from a rocket engine interacts with the atmosphere, creating a visible plume and a significant amount of noise. On the Moon, however, the absence of an atmosphere means that the exhaust gases from the lunar module's descent engine would have expanded rapidly upon exiting the nozzle, becoming invisible to the naked eye within a short distance. Furthermore, the lunar surface is covered in a layer of fine, powdery regolith, which behaves differently than loose soil or sand on Earth. Due to the Moon's low gravity and the lack of air resistance, the dust particles kicked up by the lunar module's engine would have followed ballistic trajectories, settling quickly and without creating a large lingering dust cloud. The skeptics' argument also overlooks the fact that the lunar module's descent engine was throttleable, allowing the astronauts to adjust the engine's thrust and control their descent rate. During the final stages of landing, the engine's thrust would have been significantly reduced, further minimizing the amount of dust disturbance. Section 4, the radiation riddle. A trip too perilous? The Van Allen radiation belts are two donut-shaped regions of charged particles that encircle Earth. Named after James Van Allen, they pose a significant radiation hazard to spacecraft and astronauts. Moon landing deniers argue the intense radiation would have been lethal to the astronauts. NASA took meticulous precautions to mitigate the radiation exposure. The Apollo spacecraft's trajectory minimized time in the belts. Equipped with radiation shielding, the spacecraft protected the crew. Section 5, the American flag's unnatural wave. The American flag on the lunar surface is a symbol of human achievement. Conspiracy theorists point to the flag's movement as proof of a hoax. In the vacuum of space, how could the flag be waving? NASA's design included a telescoping pole with a horizontal crossbar. The flag's movement is due to this design and the Moon's low gravity. Another anomaly seized upon by moon landing deniers is the apparent absence of a blast crater beneath the lunar module's descent engine. They argue that the powerful engine, responsible for slowing the module's descent and ensuring a soft landing, should have carved out a significant crater in the lunar surface. The lack of such a crater, they contend, is a telltale sign that the landing was staged and the lunar module was simply placed gently onto a prepared surface. This argument, while seemingly plausible on the surface, ignores several key factors. Firstly, the lunar module's descent engine was throttleable, allowing the astronauts to significantly reduce the engine's thrust during the final stages of landing. This ensured a gentle touchdown, minimizing the force exerted on the lunar surface. Secondly, the lunar surface is not a uniform, easily excavated material like loose soil or sand. It is covered in a layer of regolith, a fine, powdery material created by billions of years of meteorite impacts. Regolith, while loose, is also surprisingly cohesive, capable of compacting under pressure. Furthermore, the skeptics' argument often fails to account for the wide, flat landing pads attached to the bottom of the lunar module's legs. These pads, designed to distribute the module's weight over a larger area, would have further reduced the pressure exerted on the lunar surface, minimizing the likelihood of creating a deep crater. Moon landing skeptics often cite the absence of stars in lunar photos as evidence of a hoax. They argue the black sky proves the landings were staged. The truth lies in photography principles and lunar lighting. The lunar sky appears black, and stars are too faint for the cameras. Fast shutter speeds and small apertures limited light, missing the stars. The moon landing hoax theory thrives on skepticism and selective interpretation of evidence. Proponents argue shadows in Apollo photos suggest multiple light sources. However, perspective explains this illusion, much like parallel tracks appearing to converge. The lunar surface's unevenness further contributes to shadow variations. A comprehensive examination shows shadows are consistent with the sun as the single light source. Moon landing deniers often point to the smooth background in Apollo photos as evidence of a fake backdrop. They claim NASA used painted backdrops, citing the lack of expected detail. This argument ignores Earth's atmospheric scattering, which affects our visual perception. The Moon's thin atmosphere means less light scattering, making distant objects appear clear. Thus, lunar landscapes appear sharp and distinct, unlike Earth's hazy views. The Apollo lunar module, designed to transport astronauts to and from the lunar surface, has faced scrutiny from skeptics. They question the lack of a visible exhaust plume or dust disturbance during its final descent. This misunderstanding ignores the physics of rocket propulsion in a vacuum. In space, exhaust gases expand rapidly, becoming too diffuse to see. Additionally, lunar regolith is compacted, resisting erosion by the module's exhaust. One of the most enduring arguments against the moon landing concerns the Van Allen radiation belts, two donut-shaped regions of charged particles that encircle Earth. These belts pose a significant radiation hazard to spacecraft and astronauts. Moon landing deniers suggest the intense radiation would have been lethal. However, NASA took extensive measures to mitigate the risks. The Apollo missions were meticulously planned to minimize radiation exposure. The trajectory was calculated to minimize time in the belts. The spacecraft followed a path that skirted the edges, reducing exposure. The Apollo spacecraft was equipped with radiation shielding. The Van Allen belts were not an insurmountable obstacle thanks to careful planning and effective strategies. Section 5, the flag's ripple. A matter of design, not deception. The American flag on the lunar surface is iconic, symbolizing human achievement. Conspiracy theorists argue the flag's movement proves a hoax. The flag's movement is due to a telescoping pole with a horizontal crossbar. Astronauts' actions caused the flag to ripple and wave. The waving flag is a testament to the Apollo program's innovative spirit. Section 6 regolith and the missing blast crater. Moon landing deniers argue the absence of a blast crater beneath the lunar module's descent engine is proof of a staged landing. They claim the powerful engine should have created a significant crater. However, the engine's thrust was reduced during landing, ensuring a gentle touchdown. Lunar regolith is compacted and resistant to erosion, unlike Earth's soil. The wide landing pads distributed the weight, minimizing surface disturbance. Thus, no significant blast crater was created. Section 7. Stargazing on the Moon: Why the Stars Don't Shine in Apollo Photos. Skeptics often point to the absence of stars in lunar photos as evidence of a hoax. They argue the black sky proves the landings were staged. This stems from a misunderstanding of photographic principles and lunar lighting. The Moon has no atmosphere to scatter sunlight. This results in a black sky, even during the day. On Earth, the atmosphere scatters sunlight, making the sky blue. This scattering makes stars invisible during the day. At night, without scattered sunlight, stars are visible. On the Moon, no atmosphere means no scattered light. The bright lunar surface makes stars too faint to see. Apollo cameras were set for bright lunar conditions. Fast shutter speeds and small apertures were used. These settings couldn't capture faint stars. Astronauts could see stars, but cameras couldn't capture them. Conspiracy in the zeitgeist, the moon landing in popular culture. The moon landing, a triumph of human ingenuity and a testament to our collective ambition, has ironically become a fertile breeding ground for conspiracy theories. This extraordinary achievement, far from uniting humanity in a shared sense of awe and wonder, has become a cultural battleground, a lightning rod for skepticism, distrust, and the enduring allure of the unknown. The moon landing hoax theory has permeated popular culture, weaving its way into films, television shows, books, and countless online forums. It has become a staple of conspiracy-themed entertainment, often portrayed as a tantalizing mystery, a puzzle box waiting to be unlocked by discerning truth seekers. From the cult classic film Capricorn 1, 1978, which depicts a faked Mars landing, to episodes of The X-Files and countless documentaries on the History Channel, the notion of a staged moon landing has been explored and exploited for its dramatic potential. These fictional portrayals, while intended as entertainment, often blur the lines between fact and fiction, inadvertently lending credence to the conspiracy theories they depict. The internet, with its boundless capacity for information dissemination and its echo chambers of like-minded individuals, has further amplified the reach and resonance of the moon landing hoax theory. Online forums, social media platforms and video sharing websites have become virtual gathering places for conspiracy theorists, where they can share their beliefs, dissect evidence and reinforce each other's convictions, often insulated from dissenting voices or factual rebuttals. The allure of distrust, questioning authority and embracing skepticism. The moon landing hoax theory persists, reflecting a deeper current of distrust in society. In an era of political polarization and fake news, conspiracy theories offer alternative narratives. They thrive on skepticism, presenting themselves as critical thinking. However, they often reject any evidence that contradicts their worldview. The moon landing hoax taps into distrust of government, fueled by historical events. Echo chambers and filter bubbles, how the internet fuels conspiracy theories. The internet, while a powerful tool for education and communication, has also become a breeding ground for misinformation and conspiracy theories. Its vastness and anonymity make it an ideal platform for fringe beliefs and echo chambers. Search engines and social media create filter bubbles, reinforcing users' existing beliefs. This means users interested in conspiracy theories see more similar content, reinforcing their beliefs. The internet's anonymity allows misinformation to spread with little accountability. Social media's emphasis on sharing and emotional content amplifies misinformation, influencing public opinion. Section 4, the psychology of belief, cognitive biases, and the search for patterns. Our brains are wired to seek patterns and find meaning. This can lead us to see patterns where none exist and embrace emotionally satisfying explanations. Cognitive biases like confirmation bias and illusory correlation make us susceptible to conspiracy theories. Conspiracy theories offer a sense of order in a chaotic world, tapping into our emotions and need for control. The enduring legacy of Apollo. The moon landing hoax remains just that, a theory at odds with scientific evidence and first-hand accounts. The Apollo missions represent a pivotal chapter in human history. Armstrong's first steps inspired generations to dream bigger. Technologies from the space race revolutionized our world. Apollo inspired a generation of scientists and engineers. The moon landing was a triumph of human ingenuity. Embracing curiosity and critical thinking in a world of misinformation. The moon landing hoax theory highlights the power of misinformation and the need for critical thinking. We live in a world awash in information, much of it unreliable or false. Navigating this landscape requires critical evaluation of sources and distinguishing fact from fiction. Curiosity drives scientific inquiry and is essential for combating misinformation. A curious mind seeks evidence and considers alternative viewpoints. Curiosity compels us to dig deeper and ask why and how. Critical thinking helps us analyze information objectively and form well-reasoned conclusions. It requires skepticism, questioning assumptions, and willingness to change our minds. The Moon Landing Hoax theory reminds us of the dangers of unchecked misinformation and the importance of critical thinking. Section 3. The unquenchable spirit of exploration ad astra per aspera. The human spirit is one of insatiable curiosity, an unquenchable thirst for knowledge, and a relentless drive to explore the unknown. From seafarers to astronauts, humanity has always pushed boundaries, reaching for the stars. The moon landing, a defining moment, stands as a testament to this spirit. It was a triumph of human ingenuity, overcoming insurmountable challenges. But the journey does not end there. As we stand on the precipice of new frontiers, the spirit of exploration burns brighter than ever. We are explorers by nature, driven by a need to understand ourselves and the universe. Ad astra per aspera, to the stars through hard